Welcome back. Today we're going to start adding and subtracting polynomials. Before we get started, let's get it going on the warm-up. I'd like you to write the following polynomial and then answer the 4 questions. When you're done, unpause the video and check your answers. So when you look at these answers, how did you do? Did you put the term with the highest exponent first? And then as you go, are the exponents decreasing in order? You'll notice the exponents go down 4, 3, 2, and then 1. So we are now in standard form. It is considered a 4th degree polynomial because that is the largest exponent in the polynomial. The leading coefficient is the coefficient or number attached to the variable that leads the whole polynomial. And since the 4 was the highest exponent, the coefficient on that term is the 6. And then when I ask the number of terms, you are simply counting. We have 6t to the 4th, t to the 3rd, 5t squared, 4t, and 6. That is 5 terms. Okay, take a moment. The objective is nice and short today. You're going to write, I will be able to add and subtract polynomials. That's it. Take a moment to copy that down, pause if you need to, and move on when you're ready. Okay, we're going to start with some basics with adding polynomials. The rules are basic. Number 1, you add the coefficients by combining like terms. Make sure your final answer is written in standard form, meaning the term with the biggest exponent comes first. Little side note you want to make sure is in your notes. When I say to add the coefficients of like terms, they must have the same variable and be to the same power in order to be considered like terms. When you are ready, move on to the next slide. Here's the first example I'm going to guide you through. We have 9x plus 4 plus x minus 7. They are in parentheses, but there is no number outside the parentheses to distribute. So we are going to go ahead and add our like terms. When I look at the two binomials, 9x plus 4 and x minus 7, 9x and x are both like terms. If I add 9x plus 1x, that will give me 10x. The numbers, the constants on the end, 4 and minus 7. 4 minus 7 is negative 3. So when I add like terms, 9x plus 1x is 10x, 4 plus a negative 7 is negative 3. The final answer is 10x minus 3. There is no equal sign. We are not solving for x just yet. That'll be in about a week. When you're ready, move on to the next example. Take a moment, add the coefficients of the like terms, and when you're ready, come back and check your answers. Were you able to get to negative 2x squared plus 11x minus 4? When you look at the like terms, negative 4x squared and 2x squared are like each other. So we are going to look at negative 4 plus 2, and when we combine, that equals negative 2x squared. When I look at the x's, we have 5x and 6x, which equals 11x. The constants are negative 7 and positive 3. When you combine those like terms, you will get the negative 4. So your final answer is a second degree trinomial. Second degree because the highest exponent is a 2, and it is a trinomial because there are 3 terms. If you need to make any corrections, please do so now. Now we're going to take a moment and look at subtracting polynomials. The only thing that is different is the first step. We will need to distribute that subtraction sign, which is like a negative, to the second polynomial. After we do that, the rules will be the same as in adding. We will add the coefficients by combining like terms. Remember, like terms means the same variable to the same power. When you're done, make sure your answer is written in standard form. When you're done copying that down, go ahead and move on to the next slide. Here's our first example. We want to distribute that negative to all of the terms in the second set of parentheses. We will distribute it here, here, and here. So I'm going to rewrite the first trinomial because we are not doing anything with it. If I now distribute that negative, that would become a negative 4x, a positive 5, and a minus 3x squared. That is because I am multiplying a negative times the original signs. Now that I am done, I can combine my like terms. Pay attention and watch the signs in front of the numbers. If I take the largest exponent first, I would be combining 2x squared and negative 3x squared. The next biggest exponents are just x to the first power, so I'll combine those. And then finally, we have the constants, the 3 and the plus 5. Now you can go ahead and combine them. Like terms are the same power with the same variable. So 2 minus 3 is a negative 1 or negative x squared. Negative 2x and negative 4x is negative 6x. 3 plus 5 is 8. Our final answer is negative x squared minus 6x plus 8. Take a moment, make sure you are okay with distributing that negative to all three terms only in the second set of parentheses, because that subtraction sign is in front of the second set of parentheses. When you're ready and have that all down, move on. So here's a new example. I'd like you to write it down and then pause the video, distribute your negative, and then combine your like terms. Come back to check yourself when you're done. How did you do? Were you able to get negative 2x to the third minus 8x squared plus 4x plus 1? If not, I'm going to go through and show you to distribute the negative first, and then we will combine like terms. Are you okay with how you distributed the signs? Check your signs. I'm going to go ahead and rewrite the first term because we didn't do anything with it. Now that I have the first polynomial written, I'm going to underline and color code my like terms. I'm going to choose to start with the biggest exponent, which is 3. I will combine those, then I will do the x squareds, then the x's, and then the constant, the plain number on the end. What I've done is I've put the like terms near each other. If you are okay with scanning across the whole thing, you don't have to write them out this way, but if you are visual like I am, you may want to see them grouped together. Now I can add or subtract the coefficients. And you will see we end up with the same answer. Take a moment to make sure you have that down. Now we're going to see where you might actually use this in your very near future. If we want to find the perimeter of a shape and we know the values to be 2x, 3x, and 3x plus 5. If you recall, perimeter is to add up all the sides. So I'm going to write up all three sides. So I have now written all three sides. We're going to add the 3x plus 5 plus the base that's 3x plus the height that is 2x. Now we're going to combine like terms. There are three terms that have x's on them, so we're going to add them. 3 plus 3 is 6, plus 2 is 8. 8x. There is only one number, so there is nothing to combine it with. The perimeter can be represented as 8x plus 5. Here's the next example, same idea. I would like you to write down the example and then see if you can find the perimeter. It might be helpful to label the other two sides so that you see everything written out. If you do that, it would look something like this. So go ahead, pause the video, write out the statement that you're going to add all four of those lengths and heights together, and then combine your like terms. When you're ready, unpause the video and see if you made it to the right answer. Were you able to write the fact that we have x plus 3y twice, because it is here twice for the heights? Did you see that you had 5x plus 4 twice? Once for the top and once for the bottom. When you combine your like terms, you will end up with, there are 12 x's, plus there are 6 y's, plus 8. Take a moment to make sure that you can find those like terms. The 12x came from, there's 1 here, plus 1 here is 2, plus 5 more is 7, plus 5 more is 12. The y's came from, there's 3y plus 3y is 6y, and the 8 came from the plus 4 and plus 4. Make sure you are good to go. The next one is a little interesting. You might want to label what you know, and then we can figure out the rest. If the bottom base is x plus 1, that would mean the top base is also x plus 1. So far, our perimeter, we have 2 x's, but the whole perimeter is 16x. So that means I have 14 x's left to use. I'm going to give half of them to each height. So I'm taking my 14 and cutting it in half. 7 of the x's go here, 7 of the x's go here. When I look at the constants, I have 1 plus 1, which is 2. So I've used up 2 of the 8. That means I have 6 left. Can you guess how we're going to split that evenly? We're going to put 3 here, and the other 3 over here. The question says to find the missing side length, which we did. It is 7x plus 3. The next one looks a little more intimidating because it goes to the squared power. However, it is still the same idea. Take a moment, pause the video, see what you can figure out. Can you find the length of, or the height of this triangle? All right, let's check and see how you did. We have 6x squared and 8x squared, which means we've used up 14 of our x squareds. That leaves me with only 1x squared for the height. Let's look at the x terms. We have 3 minus 4, which is negative 1. Which means we have 4 x's remaining for the height. The last one to check is the constants. We have 12 plus 1 is 13. So we've used up 13 of our constant numbers, which leaves us with 15. That means the height of this triangle can be represented as x squared plus 4x plus 15. Take a moment and see if that sinks in, or if you want to replay it. We basically subtracted what we used for the leg and the hypotenuse to find the other leg. All right, we have one more example where we're going to apply the polynomials to a real-life situation. A quarterback throws a football, and the height in feet after t seconds can be modeled with the following quadratic function. H of t is equal to negative 16t squared plus 62t plus 8. The first question says, what is the height when the football is thrown from t equals 0? Well, that means I'm going to sub in a 0 wherever I see the t. So that would look something like this. H of 0 equals negative 16 times 0 squared plus 62 times 0 plus 8. Well, we all know anything times 0 is 0. So when we go to finish solving this problem, 0 squared is 0 times 16 is 0. 62 times 0 is 0. We are simply left with 8. That means the height is 8 feet after, or at 0 seconds, which is the starting height. The next question is the same idea, where we want to know how high the football is after 2 seconds. So now you're going to sub in a 2. So take a moment, sub it in, and then come back and check your answer. So how did you do? Were you able to simply sub it in? If we now do order of operations and we take care of our exponents first, 2 squared is 4. That leaves us with negative 16 times 4 plus 62 times 2. Next, I can go ahead and do the 2 multiplication problems. That would be negative 64 plus 64. Excuse me, 62 times 2 is 124 plus 8. If we combine those, negative 64 plus 124 is 60. And if we take that 60 plus 8, we will end up with a height of 68 feet. Take a moment to make sure you have all of that down, because that does conclude our lesson for today. If you have any questions as we went through the notes, please star it or mark it so that you can talk with me tomorrow in class about it. I'll see you soon.